Hi everyone, I am Dr.P.S.V.Shanmukhi, Associate Professor, Department of Physics, Aditya University. Now I am going to discuss about the resolving power of the grating. So at the end of this lecture, the students will be able to understand the grating instrument. What is the grating instrument? They can understand. And also they will learn about the resolving power. What is the resolving power? What is the use of this resolving power of the grating? That what the students will understand at the end of this lecture. Coming to the grating. What is actually the grating? Grating is an optical instrument. It is used to study the diffraction of light. It is an optical instrument. To study the diffraction pattern, we use the grating instrument. Okay, generally why we need this kind of grating? In general, to get the diffraction pattern, the foremost or the essential condition is the width of the slit must be the order of wavelength of light. When the light is passing through a slit whose width is comparable to the wavelength of light, then what happens? We observe the alternate maxima and minima. Here, the width of the slit D should be comparable to the wavelength of light. That is why ordinary windows, ordinary slits, they are not at all suitable to observe the diffraction pattern. We need the special instruments called gratings. So what is a grating? It is an optical instrument. Just simply it is made up of either glass or plastic. Generally we go for glass. On that one there are several lines drawn. They are called rulings of the grating. Actually they are invisible with our naked eye. On that one there are so many lines are drawn. Nearly 10,000, 15,000 lines, 20,000 lines are drawn per inch. A sophisticated grating contains nearly 15,000 lines per inch. Inch means 2.54 centimeter. Anyhow, with that much of those many lines, what is the separation of the slits? That is given by E. Actually, except these lines, those lines are called rulings. Except the lines, remaining part is blackened. The remaining part is black coated. That's why it acts as opaque to light. It does not allow the light to pass through. So anyhow, light is passing through only these rulings, and it will produce the diffraction pattern like this. Alternate maxima and minima. Okay, anyhow, now coming to the resolving power. What is meant by resolving power? Resolving power means it is the ability of an optical instrument which gives two separated images for the two objects which are very close together. Suppose two objects were very close together, two dots are very close together. How do we see these two objects? Simply the light is incident on this one and the reflected light is coming say, and the light is incident, it is a reflected light. So these two light rays will incident on the eye, on the retina, and they will produce the images. Actually there is a concept, each image is a diffraction pattern. Each image is a diffraction pattern, means from the first object one diffraction pattern is coming like this, and from the next one also another diffraction pattern. These two diffraction patterns, suppose they are superimposed, they will produce only one pattern. That's why our eye is unable to resolve the two objects. Our eye cannot identify there are two objects. In such a case, we take the external aids like the specs. We wear the specs. Suppose if these two diffraction patterns are separated by our eye, eye is also an optical instrument. So it is separating these two images, say, okay, automatically we can observe those two objects as separated objects, otherwise we can't. Anyhow, there are so many optical instruments, all the optical instruments contain the resolving powers. Even we use nowadays the mobile phones, their backside of that one there is a camera, that camera contains some resolving power. So more resolution is there, so automatically more costly it is. Anyhow, the resolving power is very much essential feature nowadays to get the clear pictures. Generally, the resolving power R is given by lambda by d lambda. What is this lambda, d lambda, etc.? Two wavelengths lambda and lambda plus d lambda. I am just saying this is lambda plus d lambda. the two wavelengths are said to be just resolved if they satisfy the two equations simultaneously. The two wavelengths lambda and lambda plus d lambda. For example, sodium light contains two wavelengths. With our eye we cannot identify that one, it seems to be yellow only, but actually two wavelengths are there. What are those two wavelengths? 5890 angstroms and 5896 angstroms. So one is lambda, second one lambda plus d lambda. One is 5890 angstroms, 5896 angstroms. So the what is d lambda in this one? 6 angstroms. Very small difference it is. With our eye we cannot identify that one. It is very difficult. That's why if the sodium light is passing through the prism, so what happens? It will produce two lines. You keep any photographic plate on this one, you will get two lines here. They are called D1, D2 lines. Anyhow, that is actually taken as conventional monochromatic light with 6 angstroms difference, very small difference. That's why in the laboratories we take sodium light as the monochromatic, but exactly 100% it is not perfectly not monochromatic light. Why? Because two wavelengths are there. Monochromatic light means not only single color, single wavelength must be there, but there is no other go for us in the laboratories to study the interference, diffractions, all those things. We are using the sodium light as the monochromatic light. Okay, we can take it, no problem. Now I want to resolve these two wavelengths lambda and lambda plus d lambda. For that one I am using this instrument, grating. Grating is acting like a resolving instrument. Resolving power is given by R is equal lambda by lambda plus d lambda. That means two wavelengths lambda and lambda plus d lambda are said to be resolved if they satisfy these two equations simultaneously. Already grating equation we know, E sin theta is equal to n lambda or k lambda. Okay, so where k is the order of the spectrum, instead of k now I am taking this n. So E sin theta is equal to n into lambda plus d lambda, E sin theta is equal to n lambda into lambda by n. If these two equations are satisfied simultaneously, automatically we say that the two wavelengths lambda and lambda plus d lambda are said to be resolved. So on simplifying this one, we get lambda by d lambda, it is equal to n into n. This is actually called resolving power. The resolving power R is equal to either lambda by d lambda or small n into capital N. What is that small n? Small n is the order of the maximum, whether it is the central maximum, first order, second order, third order. Capital N, it is the number of lines on the grating exposed to the light. How many lines are exposed? Not the total number of lines exposed to the light. So using this formula we can determine the resolving power of the grating. If more resolving power is there, more resolution we get and more clarity pictures we can get from that optical instrument. So here, so once again observe what is meant by resolving power of the grating. It is the ability of the optical instrument which gives two separated images for the two objects which are very close together. So anyhow, coming to there is one criterion called Rayleigh's criterion. The Rayleigh's criterion for resolving power. The two wavelengths lambda and lambda plus d lambda, suppose this is lambda, lambda plus d lambda, these two are said to be resolved if the first maximum, central maximum of one wave superimposes on the first minimum of the next wave. If the central maximum of one wave superimposes on the first minimum of the next wave, that is said to be, then only the two waves are said to be resolved. Suppose observe this diagram. Here the two central maxima superimposed. That's why what we get, these two are not at all separated. These two are not separated. And coming to this one, here also you observe almost the two central maxima superimposed. Again here also no resolution at all. And consider this one. In this case you observe the central maxima of one wave and the coming to the first wave, next wave's first minimum. Central maximum of one wave, first minimum of the next wave. These two superimposed, automatically we say that the two wavelengths are said to be resolved. Then only if the two dots are there, those two are resolved with the instrument, we can see those two objects as separated objects. Otherwise, those two merged together seems to be just like only one dot there. That means, as per the Rayleigh's criterion, the central maximum of one wave superimposes on the first minimum of the next wave. Then only the two waves are said to be resolved. So, in this way, we can understand the resolving power practically also. This is the resolving power mathematically, that is lambda by d lambda or n into capital N. So, in this class, we have discussed what is the grating instrument, what is the grating instrument, or how the grating is designed, how many lines may be there in general, that what we just discussed here. And anyhow, what is the resolving power of a grating? What is the general resolving power? What is the resolving power of the grating? And what is the Rayleigh's criterion? All those things we have discussed here. Thank you very much.